Hello, this is a video tutorial on using Universal Radio Hacker to analyze an RF signal that was previously recorded with a software-defined radio such as a HackRF1 or an RTL SDR. Recently, in the Great Scott Gadgets Discord, a question was posed from a student looking for assistance on how to analyze a signal. I figured this would be a good opportunity to go through some of the features of Universal Radio Hacker to accomplish such a task. Now, Universal Radio Hacker is a very powerful tool. It includes not only interpretation and analysis, but also signal generation and simulation. We won't be covering the more advanced use cases of Universal Radio Hacker today, but the more simple use case of how do we analyze an RF signal and how do we pull some bits and bytes out of it. The first step into beginning signal analysis with Universal Radio Hacker, besides of course installing it, is to drag and drop the signal file into Universal Radio Hacker. The very first thing that will appear is the Interpretation tab. The Interpretation tab will show you an analog waveform of the signal. It'll provide a number of options that we will need to tweak in order to get some usable information out of this signal. Let's take a look at some of the basic characteristics of this waveform. This signal file appears to have two large transmissions with some noise or non-transmissions in between. Let's zoom in using the mouse wheel and see if we can discern any information from these transmissions. Now, what is starting to become apparent to me is that these large transmissions don't appear to have any kind of useful information in them. I know this from my previous experience in analyzing these kinds of files. We would have expected to see some kind of waveform in here. What this looks like is noise. So right off the bat, this does not look very promising. Let's dig in a little further. We're going to switch the signal view from analog to spectrogram. The spectrographic view will begin to tell us a little bit more of a story on what's going on inside of this file. Now, software-defined radios are very powerful tools. They can record a large section of the spectrum simultaneously. And in fact, we begin to see that here. This is a 4 megasample per second capture, so presumably we have about 4 megahertz of information here. Those two very large bursts of transmissions are clearly obvious in the spectrogram view. Let's adjust some of the coloring for the min and max data to try to make some of these transmissions pop a little bit more. Okay, now we get even more of the story. It looks like, aside from the large noise transmissions, there appears to be some kind of actual signal buried inside of here. Not only that, but this symbol appears to be duplicated, as these two waveforms look identical. So what can we do about this? How can we clean up this signal and extract just the data information that we are looking for? It just so happens that Universal Radio Hacker has a very powerful facility to do just that. From the spectrogram view, if you click and highlight and drag, and then right-click on the selection, we have an option to apply a bandpass filter. Let's do that now, and let's create a filtered version of this signal. What Universal Radio Hacker will do now is apply that filter and show it as a second signal in the view down below. Since we are no longer interested in the signal that has the noise in it, I'm going to close it with the red X. Now that we have the filtered signal, let's just quickly check the spectrogram again and see what it looks like. And it looks just like the previous one, except we've filtered out all of the extra noise and are left with just this data signal here, or what we think is data anyway, to analyze. Great. Let's go back to the analog view. Now, again, I'll use my mouse to zoom in here. And at first glance, it doesn't really look like there's anything in here. There's just a tiny kind of wiggly line. However, if we increase the Y scale and we begin to zoom in here, we begin to extract some really interesting information. There is clearly now a signal inside of this file. We can see that represented here by the transmission and non-transmission periods of this carrier wave. Just from my initial thoughts, this looks like perhaps it's some kind of on-off keying scheme where maybe a digital 1 is represented by on and maybe a digital 0 is represented by off. That's probably what's going on here, but let me not get ahead of myself. In order to have Universal Radio Hacker begin to make sense of this data, we have to begin to configure these options on the side. The very first option that we'll look at here is the noise floor, which is defaulted here at 0.0250. The pink area surrounding this signal is the noise floor. Now, this is not configured correctly here because we're telling Universal Radio Hacker that the whole signal is noise. We don't want to do that. We want the noise floor to only cover the parts of the signal that are not transmitting. So let's start to bring this down a little bit until it covers only the parts of non-transmission. So that's still too high. Let's see if we go with 0.7. That's still a little bit too high. Let's go with 0.5. Now we're getting a little closer. Let's cut it down even more. Okay, so this looks to be about where we should have the noise floor. What we're telling Universal Radio Hacker here is anything that is not in the pink is considered a signal. And we can see down here in the decoding view that it's already kind of trying to make sense of things, but it hasn't gotten it quite right yet. The next section that we're going to look at is the samples per symbol. And this is arguably the most important and sometimes the kind of a hard one to get. We need to tell Universal Radio Hacker how many samples of this file represent one symbol, meaning one digital 1 or 0, or one full up and down of the sine wave, for example. Now, again, Universal Radio Hacker provides us with a very easy way to do that. If we zoom in to the analog view and we click to highlight and drag it and go from peak to peak at approximately the same distance, down here we can see it says 410 selected. This 410 represents the number of samples. If we kind of eyeball it and look around here, this one maybe is about 407, 402. That one was 410. Roughly, it looks like this is about in the 400 range. Just from my experience, usually the samples per symbol are around whole numbers. So I'm going to go with 400. And I'm going to set the error tolerance to 10. We can see that here. Now that we have set the samples per symbol and the error tolerance, we begin to see that we're starting to get some interesting bits of information in the decoder view. Universal Radio Hacker is starting to make sense of this data. It's saying here that it thinks that this is a 1 here, and the next one is a 0, and the next one is also a 0, but the next one after that is a 1, 0, 0, 0, 1, 0. And we can see that these 1s and 0s are now corresponding to the transmission and non-transmission parts of this file. Now, because we suspect this to be some sort of on-off keying where there is signal when there's a digital 1 and there's not signal when there's a digital 0, we could probably use amplitude shift keying for the modulation scheme here. So this video is not necessarily a video tutorial on what all the different modulation schemes are. Maybe I'll make one for that later, but essentially we're relying on the amplitude of the signal to tell us when it's a 1 and when it's a 0. The next important value that we need to set is the center. And for that, let's switch to the demodulated view. So in this view, we can see what Universal Radio Hacker thinks the demodulated signal looks like. And if we get past the initial noise, we can see that it's starting to make some pretty good determinations on what the digital signal appears to be. The way that we set the center is by selecting this area between the green and the pink. When you click this area, you will see a 1 and 0 appear on the right-hand side. You'll want to set this to the midpoint of the signal. Anything in the green area is considered a digital 0, and anything in the 1 area is considered a digital 1. Let's zoom in a little bit more on the y-axis. So here what we're saying is that, for example, this should correspond to a 0, while this should correspond to a 1. And if we count the samples, like 400 samples, 400 samples, 400 samples, this should represent a series of 1s. And if we look here in the decoded view, it will very conveniently also highlight the area that we have highlighted in the demodulated view. And we can see that, in fact, this is a 0, this is a 1, a series of digital 1s, 1, 0, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0. So this is starting to look like we've nailed the settings. The decoding is coming through very clearly and cleanly now. What do we do with these 1s and 0s now that we have them? So let's take a look at the hex view, because oftentimes that's a little bit easier to analyze. And we begin to see some interesting data. This appears to be a repeating signal of some kind, starting with a series of 1s and then going into some data. And then again, a series of 1s and then going into some data, a series of 1s and going into some data. So the series of 1s is probably a preamble of some sort to indicate the start of a signal. And then we actually have the data for that signal here. Now, what this data is, my guess is as good as yours at this point. I don't know where this signal was recorded from, so I can't tell for certain. Let's just take a long shot and switch to the ASCII decoded view. Yep, in this case, we don't really get anything useful here. This data does not appear to be text in nature. It is binary in nature. It means something to some system, but we don't know what exactly. So, the next step from here would be to basically take all of this data, copy it out, and then begin maybe doing some kind of protocol analysis on here. Now, conveniently, that's actually the next step that Universal Radio Hacker offers here in the analysis tab is, being able to analyze the conversation and the protocol but I'm going to save that probably for another video. This step right here is sufficient for most simple protocols, especially those ones that I'll put in a textual format. You can dump the ASCII and see it plain as day. Or you can copy this hex into a protocol analyzer of your choice and go from there. But this is the overall workflow that I go through when analyzing any kind of unknown digital signal and being able to kind of figure out what kind of signal it is. Is it amplitude shift? Is it frequency shift keying? Is it phase shift keying? And being able to pull out the actual ones and zeros for further analysis down the road. So this concludes the tutorial on how to use the interpretation section of Universal Radio Hacker. If you have any questions or comments, I encourage you to put them in the comments below. Thank you very much.